In this video, I will introduce you to Amazon Simple Queue Service, SQS, which is a fully managed message queuing service from Amazon that stands as a cornerstone when implementing intercomponent meshing in microservices and distributed and serverless function-based systems. In this video, I will guide you through how components interact when SQS is in the middle, the message lifecycle, the types of queues which SQS provides, discuss the 10 features and benefits of which make SQS an amazing service, and at the end I will give words of warning. Now, when SQS is put in between two services, it introduces an asynchronous point-to-point communication model between the two components. When components communicate via SQS, the producer component sends messages one by one or in batches up to 10 to the queue using HTTPS operations without needing to know about the consumer's state or even its existence. Consumers of a queue poll over HTTPS and receive up to 10 messages from the queue when it's ready to process them. This pool model allows for efficient message retrieval without the overhead of constant connection maintenance. The message lifecycle which SQS follows is message retention. In SQS, messages are stored until they are processed or until the message retention period expires. This period can be configured from 1 minute to 14 days, with the default being 4 days. Second is visibility timeout of messages after a consumer pulls a message. It's invisible to other consumers for the duration of the visibility timeout. If it's not deleted within this period, it becomes visible again, preventing message loss in case of processing failures. Now, message removal. Once a message is successfully processed, it must be explicitly deleted from the queue by the consumer. If not deleted, the message becomes visible again after the visibility timeout period expires. This mechanism helps in ensuring that no message is lost in case of processing failures. Because of the message lifecycle of SQS, each queue can only have one consumer. Depending on the queue type, which we will discuss in depth shortly, the consumer can be scaled and have the queue load balance the messages between processor instances. Amazon SQS offers two types of queues. The first is standard queue, and the second is first in, first out, FIFO queues. Now let's explore the 3 key differences between the queue types. The first is message ordering preservation. Amazon SQS FIFO queues ensure that messages are processed in the precise order in which they are added to the queue. To maintain this strict ordering, FIFO queues limit message processing, the throughput, to one consumer at a time for each group of messages. When a message is fetched by a consumer, it becomes invisible to other consumers. To prevent multiple consumers from processing the same message simultaneously. During this invisible period, if another consumer attempts to fetch messages, it will receive an empty response, indicating that no new messages are available for processing until the visibility timeout expires, or the message is deleted after successful processing. This mechanism helps preserve the order of message processing, ensuring that messages are processed exactly once, in the order they were sent. Standard queues do not ensure strict order, and do not have this one consumer policy, allowing multiple instances of the consumer to fetch and process messages simultaneously, potentially leading to out of order processing. The second difference is throughput. Standard queues provide a higher, near unlimited throughput compared to FIFO queues, while FIFO queues are designed to ensure the order and uniqueness of messages, which limit the rate at which messages are processed, pulled and processed. However, SQS does provide message groups, which we will discuss later. The third difference is message delivery. Standard queues provide at least once delivery, meaning messages might occasionally be delivered more than once. FIFO queues, on the other hand, provide exact once processing, ensuring each message is delivered once and remains available until a consumer processes and deletes it. Now, before I discuss the 10 features and benefits of Amazon SQS, then smash that like button and subscribe. Now, let's discuss feature number 1, which is high throughput and scalability workload management. SQS excels in handling a nearly unlimited number of messages and API calls per second. The calls are send message, receive message, and delete message. And its ability to scale automatically and process each buffered request independently ensures that the system can manage load increases or spikes smoothly, providing robust support for high meshing scenarios. 2 is enhanced system reliability. By locking messages during processing, SQS ensures that multiple producers and consumers can operate simultaneously without message loss. Standard queues deliver messages at least once, while FIFO queues maintain that strict order and guarantee exactly once processing, enhancing operations' overall reliability and integrity. The third is controlled message delivery and timing, with features like delay queues, which enable delay in processing of all messages in a queue for a certain period of time, available for both standard and FIFO queues, and the ability when using a standard queue to set individual message timers per message. SQS allows you to fine-tune message delivery schedules. The fourth feature is optimized message retrieval and processing. Long polling and batch operations optimize the retrieval and processing of messages, minimizing unnecessary API calls and ensuring efficient communication between producers and consumers. The fifth is advanced message management and customization. SQS supports unlimited queues and meshes, and you can enrich meshes with structured metadata, customize queue behavior to fit specific needs, such as integrating with Amazon S3 or Amazon DynamoDB for more significant meshes, ensuring efficient handling of diverse message types and sizes. The sixth feature is robust security and access management with server-side encryption (SSE) and comprehensive IAM policies. SQS ensures that your message data remains secure and that only authorized entities can access your queues, maintaining the integrity and confidentiality of your communication channels. The seventh feature is guaranteed message durability and high availability. Messages are redundantly stored across multiple servers and data centers, ensuring their durability and availability. SQS infrastructure is designed to provide high availability and reliability for both message production and consumption, even during unexpected traffic spikes or component failures. The eighth feature is seamless integration with the AWS ecosystem. Leverage the power of AWS services by integrating SQS with AWS Lambda, Amazon SNS, and Amazon EC2 instances, among others, to create flexible, scalable, and resilient applications that meet your evolving business needs. The ninth feature is workload absorption. During traffic spikes, SQS' remarkable capacity to absorb workload spikes acts as a buffer, storing messages when traffic surges or when consumers are unavailable or slow in processing messages. This ensures producers can continue their operations seamlessly, maintaining system performance and responsiveness. And the 10th, message groups. Message groups allow FIFO queues to enable parallel processing of messages across different groups while preserving the order within each group. This feature allows for increased throughput and scalability by letting multiple consumers handle messages concurrently without compromising the order and integrity of message processing within each group. The publisher assigns a message group ID to each message when sending it to a FIFO queue, determining how messages are grouped for sequential processing. Processors then poll the queue and receive messages from various groups as they become available, with SQS ensuring messages within the same group are delivered in the order they were sent. Amazon SQS emerges as a robust meshing solution within the AWS ecosystem. However, it's essential to acknowledge and address the potential drawbacks associated with SQS to leverage its capabilities fully. The first is latency considerations. The inherent pool-based model of SQS might introduce latency due to the need for the consumer to poll the queue for new messages actively. This aspect requires careful management of polling strategies to maintain system responsiveness. The second is polling costs. Depending on the polling method employed, particularly with long polling, costs might be related to the number of API requests made or the time spent waiting for messages to arrive in the queue. The third is message retention. Because it is a queue, it has a retention of 1. Once messages are deleted by the processor, or messages exceed the retention period, or the max 14 days, messages are deleted forever. Now, you have two options. Either go watch the video where I dive deep into when to use Amazon SQS and when you should not, or watch the induction to Amazon SNS. Or if I have not released them, watch one of the others and subscribe so you know when I do publish these videos.